Hello, this is Math 125, Intermediate Algebra. We learn Chapter 9. The title is Exponential Function and the Logarithmic Function. For the functions, we have a arithmetic operation. They are addition, subtraction, multiplication, and division. And the notation is f plus g of x equal f of x plus g of x is the two functions add together. F minus g of x is equal f of x minus g of x is subtraction. Multiplication is f times g of x equal f of x times g of x. Division is f over g of x equal f of x over g of x. Those four we call arithmetic operations on functions. Now today, this chapter 9, we are going to learn a composition of the functions, which is f circle g of x equal f of x, f of g of x. So let's give you one example. This is your chapter 9 homework example. Examples of chapter 9 homework. The first question, f of x given, g of x given, and then find a circle g of f circle g of x, which is f and g composite, and b, find out g circle f of x is g and f composite. So here, let's give you similar to your homework question number 1. First question, now f circle g of x means define equal f of g of x. G circle f of x define equal g of f of x. So for example, similar to your first homework question, example, f of x equals 3x squared minus 2. G of x equal to 4x plus 5. G of x equal 4x plus 5. And find out composite f circle g of x. So according to the definition, it is f of g of x. Now g of x, what is g of x is plug in g of x equal to 4x plus 5. And then you're looking for f of 4x plus 5. This 4x plus 5 put into f function in x, in this x. Because this 4x plus 5 put in this, you can treat like this capital X, put in this x. So this x substitute by 4x plus 5. So get 3 and 4x plus 5. And here square minus 2. Then you square it. You use a completing square formula, which is a plus b quantity square equal a square plus 2ab plus b square. A is 4x square plus 2 times 4x times 5. Add 5 square. Put the bracket minus 2. So equal to 3. 4x square is 4x times 4x. 4 square, 16. And x square plus 2 times 4 times 5 is 40x plus 5 squared is 5 times 5 is 25 minus 2. Then distributive in, remove the parentheses. 3 times 16 is 48x squared plus 3 times 40x is 120x and plus 3 times 25 is 75, then minus 2. Then simplify, combine like term and constant term combined, which is 75 minus 2 is 73. So after simplified, and this is the answer. And another one is B, A and B. B is about G circle f of x. And according definition should be g of f of x. And the g of, what is f of x? F of x given here is 3x squared minus 2. So this f of x is 3x squared minus 2. Then you And then you figure out g of this, and this you will put into g function in x. You can treat this like a capital X and put it in. This x replaced by 3x squared minus 2, and this x also replaced by 3x squared minus 2, then plus 5. And distributive in. Distributive in is 12x squared minus 8 plus 5. Combine the like term, constant term combined, got 12x squared minus 3. And that's the example. Another examples, let's see this example. This one, example. For that's the first question. Example. Let if f of x equal x squared minus 5, and g of x equals x minus 1. A, find out f circle g of x. That is equal to f of g of x. So then substitute in f of, what is g of x? G of x is x minus 1. So you put it in here. So this g of x is x minus 1. Substitute in. And you got this one. And this one, and you have to substitute this function in f function. This x. This x minus 1 put in this x. So this also put in this x. So you guys, x minus 1 squared minus 5. And square it. So you guys, x squared minus 2, x plus 1 squared, which is 1 minus 5. Combine like term. So you got x squared minus 2, x minus 4. That's the answer. Next, B. B is about g circle f of x. G circle f of x is g of f of x. G of f of x. F of x given is x squared minus 5. F of x is x squared minus 5. So this f of x is x squared minus 5. Then g of x squared minus 5, this x squared minus 5, and put into the g function. G, this substitute by x squared minus 5. So this x substitute by x squared minus 5. This is x squared minus 5, plug it in, and minus 1. Combine, and you will get x squared minus 6. So another example. Still your homework number 1 example. And the example, if you let this one, f of x equal to square root of x plus 3. And g of x equal to x squared minus 2. A, find out f circle g of x. And that is equals f of g of x. So it's f of, what is g of x? X squared minus 2. So this is x squared minus 2. Then you plug into f function. This x squared minus 2 put in f function in x. So this also put in x. So get square root of x squared minus 2 plus 3. Then we cannot further simplify. So that's the answer. And the B, looking for g circle f of x, which is g of f of x. Now what is f of x? Is the square root of x plus 3. So this f of x is the square root of x plus 3. Square root of x plus 3. Then you put it into the g function. This one put in g function in x. So this one put in this x. So get square root of x plus 3 squared minus 2. Then square it. Square root of x a squared and plus 2 times square root of x times 3 plus 3 squared. Formula, a plus b quantity squared equal a squared plus 2ab plus b squared and minus 2. So this square root and the square cancel each other is x. And this time together is 2 times 3 is 6 square root of x plus 3 squared is 9. 3 times 3 is 9 minus 2. And 9 minus 2 combine, so get x plus 6 square root of x plus 7. Another one, that's the first question. And that's about composite. And then we will talk about the inverse function. If the two functions are inverse each other, then the two functions after composite. So here we talk about composite. If this one, inverse, f we represented by f inverse of x is the inverse of f of x. So if the two functions after composite is equal x and the g circle f of x is also equal x, then we will say f inverse is g function and the g inverse, or they are inverse to each other. G inverse is f function. So the two functions are inverse to each other. In other words, f circle and g is f inverse. If f circle f inverse of x, it should be equal x. It should be equal f inverse circle f of x. And the two functions are inverse to each other. We use this inverse. This one is not equal f of 1 over f. No, it's not. This one is just a notation. F inverse, just a function. Inverse, a notation. F is not a number. 3 inverse, it's 1 over 3. No problem. 3 inverse is 1 over 3. But F inverse is not 1 over f, because f is not number. 3 is number. 3 is because the two number times together is -1, add 1 is 3 to the power 0 equal 1. So the two number times together equal 1. But it's not equal 1. It's identity function. How to find out? So here, the inverse of function denoted by f inverse of x, and represent the relation such that f of f inverse of x equal f inverse of f of x equal x. Graphically, f inverse of x represented the refraction of f of x about the line y equal x. F inverse of x does not mean 1 over f. And nor doesn't mean f inverse times x. It's because f inverse is a notation. It's just a symbol. It's not a number. So you cannot say for the number 3 times 4. This means 3 times 4. But for inverse, this is not means f inverse times x, because f inverse is a symbol. It's not a number. This is not means multiplication. So procedure to calculate for the inverse function. Here has one examples here. Procedure to calculate for example, find the inverse of f of x equal to x minus 3. And the first step, you let f of x become y. Replace f of x with y, so get y equal to x minus 3. Second, swap every x and y. X change to y change to x. Then solve for y and replace y with f inverse of x. Let me show like this example. Example for find out inverse function. Given f of x equal to 2x minus 3. and want you to find out its inverse, f inverse function. First step, you let change f of x become y equal to x minus 3. And the second, exchange y change to x change to y. The third, this is x and y exchange. The third is solve for y. So solve for y, you add 3 both sides, isolate y. So you got is x plus 3 equals 2 over y. Then you divide it by 2 both sides. 2 cancel. Then you got y. Y equals x plus 3 over 2. Then fourth step, change this y to f inverse of x equals x plus 3 over 2. That's the inverse function. So let me show you. This is x, a number. You times by 2. Then you subtract minus 3. You got this one. A number we don't know, you times by 2, got this one. Then you minus 3, and you got this one. It's the inverse, and you do add 3. Given a number, minus 3, inverse is add 3, you got here. Then inverse, here's times 2. Inverse is divided by 2, and you go back. So the inverse is going to be x plus 3 first, then divided by 2. A number, you add 3 first, then you divide it by 2. That's inverse operation. You go back to the original x. So a number, you times by 2 minus 3. A number, for example, you say 4 times by 2, it's 8, minus 3. 4 times 2 is 8. And minus 3, you got 5. And then you do 5 plus, you got 5. And then you do inverse, you add 3, you got back 8. Then divided by 2, you go back to 4. So therefore, if the two functions are inverse each other, their composite is go back to original x. So it's f of f inverse of x is x. And the f inverse of f of x is go back to x. So that's inverse function. Let's see another more examples for the inverse function. Here, your homework, number 2, question 2, homework. Find a formula for the inverse of the given function g of x equal negative 3x plus 5. Let's do this example. Example, it's given the function f of x equal to negative 2x plus 4. Then you want to find out its inverse. Find f inverse. How to do? First step, you let change f of x to y equal negative 2x plus 4. Second step, change y change to x change to y. X and y exchange. Third step, solve for y. Solve for y, like this one, you isolate y. So you minus 4 both sides. So you got x minus 4 equal negative 2y. Then isolate y, so you divide by negative 2. Negative 2 cancel. So solve for y, you got y equals x minus 4 over negative 2. The third step, write this y. Put the answer f inverse. Y replaced by f inverse of x equals x minus 4 over negative 2. And this is an inverse function. So a number, original function is given a number, and you times by negative 2. And then you add 4. Its inverse function is going to be minus, here is add 4. So you do minus 4. So given a number, then you minus 4. Here's multiplied by -2, then you divide by -2. So inverse is x minus 4, then divided by -2. That's inverse operation. Next example. Let's see another example. Here, second question, your homework. Second question. More examples. Example here. If a given g of x equal this one, 7x minus 5, and then want you find out the g inverse. Find g inverse. So same thing. First step, change g of x become y. Y equals 7x minus 5. Second step, exchange, and y change to x. X change to y. Y change to x, x change to y. The third step, then you solve for y, isolate the y. Solve for y, isolate the y. So you add 5 both sides, then divide by 7 both sides, and cancel. So you will get y equals x plus 5 over 7. The fourth step, replace y and put the answer y by g function, because given name is g. So you have to put g inverse of x is x plus 5 is this form. This. And you look at original question is a number, given a number you times by 7 and you got a number, then you subtract 5 and get the result. That's a g function. And the inverse function, you're going to add 5. Do inverse operation, minus 5. Inverse operation is add 5. Here, any number you add 5. Do inverse operation is divided. Here is multiplied by 7. Inverse operation is divided by 7. So is you can, let's see, like 3. 3 times 7 is 21. 21 minus 5, it's 16. Then inverse is 16, add 5, get 21. And 21 divided by 7, go back to 3. So that's how to find out inverse function. Let's do another examples for inverse function. Let g of x equal to this one, square root of x plus 3. And then one figure out g inverse. Find g inverse. Square root of x plus 3. So first step, change g of x become y. Y equals square root of x plus 3. Second step, y change to x. X change to y. Third step, solve for this y. Solve for this y, you minus 3 both sides. And then you square both sides. So you got x minus 3 squared equal this square is just y. And then fourth step, change this y become g. Here's g function. If given you h, find h inverse. So let's, if say h, then you y change to h inverse of x equals x minus 3 squared. So this the way procedure to find out inverse function. Now, why we need to talk about inverse function? Because we are going to learn exponential function and the logarithmic function. Now, because exponential function, the inverse function is we call logarithmic function. The logarithmic function, the inverse, we call exponential function. They are inverse to each other. So for exponential function, have the following rules. The following rules. This is on your, you can see this page. Those is your notes. In your notes. For exponential function, and the following rule. First one, we call product rule. This is exponent rule. First one is a product rule. Product rule, it's, let me see here, they use what? X. Okay, I follow that way. Here, x to the power a times x to the power b, and same base is x, you add exponent. And second one is quotient rule. Quotient rule is x to the power a over x to the power b. Then you subtract exponent a minus b. The third one is a power rule. The power rule is x to the power a, then to the power b is x to the power a times b. Power rule. The fourth one is a power rule of product. Which is xy to the power a equal x to the power a, y to the power a. This exponent go into each. Then next one, it's also power rule. Those three are power rule of quotient. Which is divide x over y to the power a. Then will this exponent go x to the power a, y to the power a. Then next one we call zero exponent rule. X to the power 0 we call zero exponent rule, which is any number x to the power 0 is always equal 1. And number 7 is negative exponent rule. Negative exponent rule is x to the power negative a is 1 over x to the power a. Those are 7 rules for exponent. For exponent, it's over here. It's over here. And those for the radical, that's for exponent. And for the radical, it's also have a product rule. Radical rule. Product rule is eighth root of x times eighth root of y equal eighth root of x times y. Product rule. And the second one is a quotient rule. Quotient rule is eighth root of x divided by eighth root of y equal eighth root of x over y, which is quotient rule. And then number 3, it's exchange. Change from radical to exponent, or from exponent to radical. So like x to the power n to the power a bth root, that is equal x to the power a over b. So that's a exchange. So those rules listing over here on your notes. Those are on your notes. You can find in files, have those notes. So common errors. 3 squared times 3 cubed is not equal 3 times 3, got 9, 2 add 3. No. And this is error. It should be base is 3. Add x exponent 2, add 3 should be 3 to the power 5. So when multiplying exponential terms, the base must be the same and remains the same. So this base is 3, need to be same. Then you multiply, product rule. Then answer is base still 3, and add the exponent. So now today we learn is a logarithmic function. Logarithmic function is the inverse function of the exponential function. And how to get logarithmic function. So let's do, given a function, the name is f, it's going to map from exponential function x map to 2 to the power x, for example, like exponential function, y is f of x equal to b to the power x. This is going to be the exponential function. B is the base. B is the base, and the x is exponent. Now, then, like if x equal 1, you will map to 2. Like x equal 2, you will map to 2 squared, which is 4. If x is 3, you will map to cube, which is 8, according this rule. So if x is -1, you will map 2 to the power -1, which is 1 over 2. If -2, you will map 2 to the -2, will be 1 over 2 squared, is 1/4. This is called exponential function. The base is 2. X is exponent. Now, its inverse function, from left to right, we call f function, given f function. Now, its inverse function is this, f inverse. So this is x mapped to y, and this is the function value is y. So it's for this example is y equal to 2 to the power x. That's an exponential function. Its inverse function, it's we call f inverse. F inverse. From this side become domain, this side become range. For f function, x is all the real numbers, and this side is domain can be all the real numbers, and the map to the range. Like 2 to the power 0. If 0, then 2 to the power 0, it's 1. If x is positive, like 1, like 2, like 3, you will get the value, it's a positive. If x is exponent, it's a negative, like 2 to the power -1, you bring down to the denominator, use negative exponent rule, and you will get 1 over 2. It's still positive. If x is negative, you got 1 over 2 squared is 1/4, it's still positive. So the range, domain, you can put any real number in x. But y value is the range. The range has to be y. Y need to be greater than, never equal 0. It's going to be positive number, y greater than 0. So the domain is all the real numbers. The range is from 0 to positive infinite, all the real numbers. A range is all the numbers, positive numbers, positive real numbers is the range. So now inverse function. The inverse function f inverse, this side become domain. So domain for the inverse function is a positive numbers, and this side become range. Range is all the real numbers. So like this question, you will say f inverse of y equal x. F of x equal y. This x map f get y. Y is, for example, y is 2 to the power x. It's inverse. Inverse. So originally it's f of x equal y. Its inverse is f inverse of y equal x. F from x map to y, and we write it's f of x equal y. Function value is y. Its inverse, domain is this side. F inverse of y equal x. F inverse of y map back to the x. That's inverse. So, for example, like this y is defined as 2 to the power x. And you can put it in general. Base is b. B is a positive number. B like 2 and like 3, like 1/2. Any positive number is the base. Now, its inverse, f inverse of y. Now, we give a specific notation for f inverse. We write is this logarithm. base. This, instead of writing F inverse, we give a specific name called log base is 2. For this example, base 2. So if you put a B, then this F inverse, we give a specific name, say log B y. This specific name is log B, and of y equal x. F inverse give a specific name for exponential function. Those we call exponential function. Give the inverse function, give a specific notation is log base. This B put on the footer of the log. So you got this F inverse become log base is B, and the y of y equal x. So from here, we got the first formula. If y equal b to the power x, this is an exponential function. You can change to logarithm function. This one, log b y equal x. That's by definition of logarithm function. We got this. Any exponential function you can change to logarithmic form. And any logarithm function you can change to exponential form. And the logarithm function is exponential functions. They are inverse to each other. They are inverse function to each other. So from here, you can get the first formula. This is the first formula. For example, give you one example, like y equals 2 to the power x, like 8 equals 2 to the power 3, right? If x is 3 and y function value 2 to the power 3, it's 8. Then you can write down log formula. It's if y equal b to the power x equivalent to the logarithm function b y equal x. So log base is 2, y is 8 equals x is 3. 2 to the power 3 equal 8. Log to 8 equals 3. 2 to the power 3 equal 8. The formula is b to the power x equal y. That's the first formula. It's come from definition of logarithm function is inverse function of exponential function. We got these formulas. For example, like 3 to the power 4, it's 81. So 3 times 3 times 3 times 3 is 81. Equivalent to what? Log base. This is y. This is base b. This is x. Y equal b to the power x equal base is 3. Put on the footer. Y 81 equals x 4. 3 to the power 4 equal 81. Go back to this. And base is 3. Function value 81 equal exponent 4. So that's exchange from that's the first formula. First formula, which is on your notes. This one. B equal to the base. Base need to be positive and real numbers and cannot be equal 1. The base cannot be negative, cannot be 0. Need to be positive and the real numbers, but not equal 1. N is the number, positive real numbers. N is a value. A is exponent, the logarithm, the exponent of b to get n. So it's like this. B to the power a equal n. Then will be log base is b, value n equal exponent. That's they put different sign symbol. So let me give you one examples, like here examples. This one, question 3, your homework number question 3. This one, convert to logarithmic equation. Given exponential function 5 to the power 6. 5 to the power 6 is 5 times 5 times 5 times 6 of 5 times together equal 15625. That's your homework question. So let's give you one example. First example. For your homework number 3. Like 3 squared equal 9. That's an exponential function. Then change to a logarithm function. Convert to logarithmic equation. Convert from exponential equation to logarithmic equation. So formula, this is the formula. Base is 3, put on the footer. Function value 9 equals exponent 2. 3 squared equal 9. That's the answer. Second question, another example, like 5 cubed equal 125. Then convert to logarithm function. 5 cubed, 5 times 5, 25, times 5 is 125. So go logarithm, the base is 5. Function value, 125, equal to exponent 3. 5 to the power 3 equal 125. This is a logarithm form. You can change from exponential form to logarithm form, or from logarithm form to exponential form. Next question, next example. This one, 2 to the power 5 equals 32. And change to logarithm form. 2 is the base, 5 is exponent. Value, function value is 2 times 2 times 2 times 2. 5 of 2 times together is 32. So log base is 2. Function value 32 equal exponent 5. 2 to the power 5 equals 32. And the next example, like this. This one, 4 to the power 5 equal 1024. This is 4 times 4 times 4. 4 to the power 5, 4 times 4 times 4 times 4. 5 or 4 product. Time together is 1024. And change to logarithm form is log base is 4. And this exponential function value is 1024. Then equal exponent 5. 4 to the power 5 equal 1024. And get exponential form. So this is the first formula. Come from definition of logarithm. Logarithm is the inverse function of exponential function. So any exponential function y equal b to the power x, you can change to logarithm function. Base is b. Function value y equal x. And then from logarithm, you can change to exponential function. It's b to the power x equal y. And you will get exponential function. And the following have a addition rule, quotient rule, and the power rule of logarithm function. And the 3 rule is also come from, we can prove it. It is actually from the exponential function, the product rule, and the quotient rule, and the power rule. We can prove it and you can see on your notes. This log base is b, x times y equal log x plus log y. That's the product rule. And the quotient rule, log base is b, x over y equal log x minus log y. Another one is a power rule. Log base is b, x to the power y. This y go from, got y, and log x. That's the 3 rules. The 3 rules you can prove by the product rule of exponent and the product rule of quotient. You can prove it. And now here we only talk about how to use it. I can prove a little bit how to prove it. How to prove here we spend a little bit time to prove it, which is we know here we are going to prove we are going to prove this product rule, this one product rule. It's log b x times y equal log x plus log y, base is b. How to prove it? First of all, you let this equal n, let this equal n. So going to prove it. First of all, you let n equals log x and n equals log y. And then you can change logarithm form to exponential form, which is b to the power n equal x. So x equals b to the power n. And b to the power n equals y. B to the power n equal y. So y equal b to the power n. And then we are looking for x times y here. We are looking for this side. This side have x times y. So I just tie together x and y, tying together. X is b to the power n and y is b to the power n, tying together. So